Hello, today we are talking about the fundamental theorem of calculus. And again, this is a different version than we have seen before. So there's, I think, 4 different parts to the fundamental theorem, and this is part 2. So this is huge, this is big, this is it. This is the big thing. It's about the accumulating aspects of the definite integral. So we're going to jump down to this function model. And we now have the function g of x is equal to the definite integral between 0 and x of f of t dt. So this is our little function model over here. We're going to input an x value, plug it into g, and out comes a number. Okay? And that will be the signed area. Signed meaning it's either positive or negative. Sorry about that. Depending on the order of our bounds and where the area is either positive or negative above the x-axis or below the x-axis. So we will get a signed number. So let's go ahead and look at this particular problem. To the right, we have a graph of f of x. So here's our graph of f of x. G is going to be the definite integral between 0 and x of f. So let's look. We're just going to plug in 0 for x, then we're going to plug in 1 for x, then 2, then 3, then 4, etc. So let's start by plugging in 0 for x. So g of 0, I'm going to replace my x value with 0, and now I have the definite integral from 0 to 0 of this function. Well, once my lower bound is 0 and my upper bound is 0, I actually have no area. So as long as these bounds are the same, the area will be 0. So g of 0 is going to be 0. Now I'm going to end up plotting this graph, but I'm going to plot it after I have found all of these values for g. So give me a moment before we start plotting. So let's look at when x is 1. So g of 1 is going to be the definite integral from 0 to 1. I replace my x with a 1 of f of t dt. Now, I know how to do that. I'm going to go look at my graph. I'm going to go from x is 0 to x is 1, and I need to find the area of this little triangular shape. I can find the area of a triangle. Area of a triangle is 1/2 base times height. In this case, I have 1/2. The base of my triangle is 1. The height of my triangle is 2. So I have 1/2 1 times 2, and when I work that out, I get 1. Simple enough. So let's move on to the next one. G of 2. So now I have g of 2 is my definite integral from 0 to 2 of f of t dt. So let's look at that area. I'm going to erase what I already had. My new area starts from 0 and goes to 2, and I now have this triangular area. So again, I have a triangle. The base is 2. My height is 1, 2, 3, 4. My height is 4. So the area is 1/2 2 times 4, which is 4. Now, I'd like to look at this a different way because I had already calculated the area from 0 to 1. So I had already calculated this green area here when I found g of 1. So actually, all I needed to do is I could have just taken the 1 and added the area of this trapezoidal region that I have highlighted in blue. So let's find the area of this trapezoidal region. The area of a trapezoid is 1/2 height times base 1 plus base 2. So this would be 1/2. The height of my trapezoid is actually a 1. Base 1 is 1, 2, plus base 2 is 1, 2, 3, 4. So that would be 1 plus 1/2 of 6, which is 1 plus 3, which gives me 4. So I prefer that we'd use this accumulating aspect where we use the area we've already found and add the next area. So that's what I'm going to do for g of 3. So g of 3 is the definite integral from 0 to 3 of f of t dt. So I already know that I was starting with 4, and now I need to add the area between 2 and 3. So I'm going to erase what I have. And now I'm going to look at the area between x is 2 and x is 3. And again, because f is a line, I have a trapezoidal region. So I'm going to add 1/2. The height of my trapezoid is actually 1. Base 1 should be 4. 1, 2, 3, 4. And base 2, I believe, is 6. 1, 2, 3, 4, 5, 6. So that's really 4 plus half of 10. So 4 plus 5, which is 9. So again, g of 4. I would like for you to find g of 4, so pause the video now, please. So I got my g of 4 to be 16. So I started with what I had, that g of 3 was 9, and I added the area of the blue trapezoid that I have. One base was 6, the other base was 8, so 1/2, the height was 1, times 6 plus 8. So now I want to stop here and kind of talk about what we have going on here. G of -1. Okay, let's plug this in. So g of -1 is definite integral from 0 to -1 of f of t dt. So my bottom bound is 0, so I'm starting at 0 and I'm going towards -1, which is going in the negative direction. Erase my trapezoid. And I want to find this area. So first let's talk about a sign, whether it's positive or negative. So this triangular region is below the x-axis, so if I were doing a definite integral, the definite integral from -1 to 0 of f of t dt would be a negative number. And that is because my change in x would be positive, because I would be starting at -1 and going to 0, but my y value is a negative number. My height of my triangle would be negative. But this isn't actually what I have. My bounds are flipped, which means the integral from 0 to -1, I'm going backwards, which means my dt is a negative number, and my y value is a negative number, which means this is actually going to be a positive entity. So the definite integral from 0 to -1 of f of t is going to be a positive number. So let's figure out what this positive number will be. So I'm going to find the area of the triangular region that I had. And the base is 1, the height is 2. So the area is 1/2 base times height, because it's a triangle, and that gives me a positive 1. So same idea for g of -2. G of -2 has a negative dx because I am going from 0 to -2. My dx is negative, sorry, dt in this case. And my f of t is also negative, so when I find the area, it will be positive. Multiplying a negative times a negative is positive. So I start with the 1, and I'm going to add the area of this trapezoidal region right here. And so that's 1/2. The height is 1, base 1 is 2, and base 2 is 4. So that is 1/2 of 6, which is 3, so this value is 4. Same idea for g of -3. So g of -3 is a definite integral from 0 to -3 of f of t dt. And that's going to be 4 plus the area of this triangular region, trapezoidal region. My height is 1, one base is 4, the other base is 6, so I have 1/2 times the height times 4 plus 6. So that's half of 10, so 4 plus 5, which gives me 9. So now that I have created this table, what I also need to do is actually graph this function. So before I'm going to graph, I'm going to erase all my work so that I can actually plot these things. So while I'm erasing, I want to think about what f of t was. And the shape of f of t is a line. It's linear. In fact, I could come up with the exact equation if I so wanted to. In this case, my slope ends up being 2. So the equation of that's really 2x. And the antiderivative of a linear, regardless of what the equation is, should be a quadratic. So let's see if we got a quadratic. Let's start plotting some points. So I'm going to plot this in red, sorry, not red, in blue. So g of 0 is 0. So when x is 0, g is 0. G of 1 is 1. When x is 1, g is 1. G of 2 is 4. When x is 2, g is 4. And g of 3 is 9. So when x is 3, I'm at 9. And if you notice, those are all square numbers. Here we have 1 squared, 2 squared, 3 squared, which is our parabola or a quadratic. Let's keep going the negative direction now. G of negative 1 is positive 1, otherwise known as 1 squared. G of negative 2 is 4, otherwise known as 2 squared. And G of negative 3 is 9, otherwise known as 3 squared. So the shape that I end up with is a parabola, as it should be. I should get a parabola because I started with a linear, and the antiderivative of a linear should be a quadratic. So this is what I get for the graph of g of x by using the fact that the definite integral is actually an accumulator. I keep adding up areas as I go. So please bring any questions that you have to class so that we can discuss this, and I hope you have a wonderful evening.